Hello, friends, and welcome to a lecture on game theory. This is Professor Arvind Prasad. In game theory, today we will study about games with saddle point. Let's take up an example. It's about winning election. You have two politicians. They are contesting from Mumbai and Pune. Mumbai and Pune are two cities in Maharashtra, India. Now, the strategy one available to both the politicians is to campaign for one day in each city. The strategy two available to both the politicians is to campaign for 2 days in Pune. Strategy 3 available to both the politicians is to campaign for 2 days in Mumbai. Now, each campaign would give you some votes. You can estimate it depending on what is your presence in the city, how popular you are, how popular your party is. One can get an estimate of what is roughly the votes you might get. Now, let's take the payoff table of politician 1. It shows that how much vote politician 1 is likely to get in case he chooses a strategy. This also has the strategy of politician 2. If politician 1 takes strategy 1 and politician 2 also takes strategy 1, politician 1 stands to lose 30,000 votes. The votes here are in multiples of 10,000. Now, if politician 1 chooses strategy 3 and politician 2 chooses strategy 3, politician 1 stands to lose 40,000 votes. If politician 1 chooses strategy 1 and politician 2 chooses strategy 3, politician 1 gains 60,000 votes. Now, let's see how we can analyze this problem. To start with, we assume that both players are rational. So, both players are rational and both of them are aware of their opponent's strategies. Rationality means, yes, you choose decisions which are based on sound analysis. And both the politicians have done sufficient groundwork to understand that if they choose any strategy and their opponent also chooses the strategy which is available to him, how much could be the gain or loss. So let's now analyze once again. Let's say if politician 1 only plays by strategy 1, what happens? He may gain 60,000 votes, but he can lose 30,000 votes too. Let's say if he takes a decision to play by strategy 3. Again here, he stands to gain 50,000 votes, but he stands to lose 40,000 votes too. Player 2, if he plays strategy 1, he stands to gain 30,000 votes, but then he stands to lose 50,000 votes too. And if he plays by strategy 3, he stands to gain 40,000 votes, but might lose 60,000 votes. So both of them being rational would gravitate towards choosing strategy 2. Now, why is that? Because if politician 1 chooses strategy 2, he stands to gain 20,000 votes or he stands to lose nothing. That is 0. And if politician 2 also plays by the same strategy, that is strategy number 2, he stands to gain 20,000 votes or lose nothing. So as we can see here, it's a stalemate. And both would naturally gravitate towards this strategy because the worst that can happen is both don't gain anything. So 1 in 3 chances for both of them that they gain nothing. Right? Here, if politician 1 announces his strategy, then too, politician 2 wouldn't have gained advantage by advanced knowledge of politician 1's strategy. Why? Once again, if politician 1 announced his strategy and politician number 2 knew it, he would know that politician 1 would stand to gain 20,000 votes or lose nothing. So with an advanced knowledge, there is nothing much he can gain out of politician 1's announcement of the strategy. So this becomes a very interesting problem to analyze. From the discussion that we had on the strategies, we can sum it up. Even if the strategies are announced by individual politicians when they are placed, or played rather, the opponent cannot really exploit it. He cannot exploit the information that the other party is playing this strategy. And the strategies are placed such or played such where each individual politician tries to minimize his maximum loss. Obviously, it was very clear in the explanation given thus far that politician plays strategy 2 because he wants to minimize his loss. That is, in case of playing strategy 2, and if politician 2 also plays strategy 2, he doesn't stand to lose anything. So he's minimizing his loss. This is also known as the minimax criterion for evaluating and playing strategies. Where in a minimax criterion, what we do is we evaluate strategies and use strategies using the criterion, or take strategies based on the criterion that it minimizes our maximum loss. What is a criterion? A criterion is a standard on which decisions are based. So the standard, of course, here is minimizing our maximum losses. Now let's revisit our payoff board. Now in the payoff board that we can see that if politician 1 plays strategy 1 or takes strategy 1, his minimum payoff is going to be minus 30,000 votes. That is, he stands to lose 30,000 votes. If he plays strategy 2, his minimum payoff is going to be 0 votes. And if he plays strategy 3, his minimum payoff is going to be minus 40,000 votes. That he stands to lose 40,000 votes. Well, obviously, he would like to maximize this minimum payoff, and therefore he chooses strategy 2. Now, from the perspective of politician 2, we can see the payoff that politician 1 receives if politician 2 takes strategy 1 is 50,000 votes. If politician 2 takes strategy 2, the payoff that politician 1 would receive would be 0 votes. And if politician 2 took strategy number 3, the payoff politician 1 would receive would be 60,000 votes. Now, obviously, he would like to minimize the payoff that politician 1 receives, and therefore he plays by strategy 2, where the payoff to politician 1 is going to be 0. So player 1 plays by the maximum strategy. Player 2 plays by the minimax strategy. If both of them played strategy 2, the payoff finally would be 0, and it's a fair game. In a fair game, what happens is, if the strategies are finally played, nobody actually wins. It's a stalemate. Now, the result of the strategy 2 played by each individual politicians is 0 votes. Now, this is the best that can happen, and this is also known as the saddle point, because evaluating all these strategies, we can only come to this point. So this is known as a saddle point. You cannot get any better from the saddle point. That is, if strategy 2 is played by politician 1 and the politician 2 does not play strategy 2, he stands to lose. Similar thing can be said for politician 1 too. That is, if politician 2 plays by strategy 2 and politician 1 does not play by strategy 2, he stands to lose. Therefore, the solution is 0. That is, it is the saddle point. There is an equilibrium point to the solution. It has a stable solution. So that was all about saddle point. That is game theory and the saddle point, and how to get an equilibrium solution. If you like this video, subscribe my channel. And of course, do share the link of this video to your friends who would benefit from it, and also ask them to subscribe it. Goodbye friends, have a great day and have a great time.